Why is the sky blue? Is a question that has crossed everyone's mind at some point in their lives. First, let's dive into the nature of light itself. Visible light is part of the electromagnetic spectrum, which also includes various other forms like radio waves, infrared and X-rays. Electromagnetism refers to transverse waves composed of electric and magnetic fields, as the name implies. So, light travels in the form of waves. Although there are instances where light demonstrates particle-like behavior, for this video it is enough to understand that light and other types of electromagnetic radiation move in waves with different wavelengths and frequencies. To understand why the sky is blue, we need to understand the light coming from the sun. To simplify matters, we can consider the sun as emitting pure white light, which includes all the various colors with their corresponding wavelengths. When this white light from the sun reaches the Earth's atmosphere, something interesting happens. Before going into the details, it's important to note that the Earth's atmosphere is composed of various molecules, primarily 78% nitrogen, 21% oxygen, and a small percentage of other molecules. When sunlight reaches these molecules, it scatters the sunlight in different directions. So, you might be wondering why the entire sky doesn't appear white as a result. To understand this, let's take a closer look at how a photon interacts with these molecules. Because light carries an electric field with it, and molecules have electrons paired to them, the molecule begins to vibrate with the same frequency as the photon. The molecule absorbs the energy of the photon and emits the energy again as light, but in a different random direction. This is called Rayleigh scattering. If we take a look at the Rayleigh scattering formula, and don't worry, I won't go into all the details for the people who don't like math, but you can see a pretty big equation that represents the amount of scattering. Don't worry about all the letters, there's only one thing important, and that is, it includes the photon's wavelength. To provide a clearer explanation, I'm going to ignore all the other variables and only focus on the wavelength and the amount of scatter. This means if we take a longer wavelength like red, we get this number. And if we apply the same formula for a shorter wavelength like blue, then this number comes out. As you can see, the amount of scatter is a lot bigger, almost 10 times bigger. But why do shorter wavelengths give more scattering? It is because air molecules resonate far better with shorter wavelengths than with longer ones. And this means they scatter more blue light instead of red light. Every wavelength does scatter a bit, but blue light is by far the most, and therefore the sky is blue and not white. I hope you learned something new during this video. If you enjoyed it, please give the video a like and consider subscribing. Thanks for watching.